Okay, I think where I come from is not that important. Where I'm going to lead you is more important. So I'm not going to bore you from who I am. I can just send you one line that I worked 15 years with the UN. I have 2 degrees in environmental economics from London School of Economics. But I was never inspired to continue with the UN. I thought life is out there. It's more fun to have startups. It's more interesting to really go with your heart what you really want to do. Otherwise, whole life you'll be just doing something which will make you unhappy. So here I am in front of you talking about environmental monitoring using commercial off-the-shelf technologies. And I'm presenting here as a startup which is basically providing low access to space technologies, to robotics, to developing countries. Because I believe that the youths have the whole power. I mean, even though we have been listening to a lot of people talking about how dismissal the picture is, sometimes in terms of the hope for the Latin American region. But I'm a very optimistic person because I believe in the end, the youths are going to cut across whatever barriers we have, and we're going to do much better. The first thing is that, yes, climate change is happening, and we are suffering from it. You know, I come from India, and we have farmers who have to grow crops in saline water simply because the water has turned saline for not of their causes. Simply because there has been overfishing, there has been over-utilization of groundwater, but they have to bear the consequences. So these are not the persons to blame, but they are the ones who are facing the consequences. So what do we do about them? And I believe that the opportunities are there. We can sit back and say nothing can be done, or we can look ahead and see what are the opportunities available for me to make a difference in my own country. We know that last year we had the Paris Climate Conference where countries came together and they recognized that climate change is a problem. And they also talked about monitoring of the emissions. Now that's something very important because it looks like a very kind of a generalized idea that why should countries monitor their emissions? But I think once the countries start to monitor their emissions, there is a whole new opportunities which open up for the youths. There are total new kind of industries which will come up, which will allow young people to have their own startups in this sector. Now, this agreement is due to come in force in 2020, and there is some financing also available globally. But are developing countries up to it? Now, what are the key issues for environmental monitoring in developing countries? Environmental monitoring is a very complex thing because you need to get data on a continuous basis. Now, if you want to monitor how the things are changing in Costa Rica, we need to get data from the sea, we need to get data from the land, deforestation happening, we need to get data from the space, what have been the greenhouse gas emissions. So it's a very complex job. It also requires technological capabilities and financial resources. Only 6 countries in the world have the capabilities to launch their own weather satellites. And without these kind of things, without these kind of capabilities available to developing countries, we'll always be left behind and always be looking forward to northern aid or northern cooperation to achieve our own domestic goals. So I feel there's another opportunity available for developing countries to work on this. And finally, I find that governments have a monopoly on environmental data. We simply trust on the information that the government gives us about the environment. Do we have alternative sources? Do we have citizen groups? Do we have other sources of data which we can triangulate what's been provided to us? Now, what are commercial off-the-shelf technologies? Now, practically, it's like Lego blocks. You have different things available, but it's up to you what you want to make from the Lego blocks. So if you want to create something for your own country which is going to measure, for example, the rate of deforestation, then you look at available technology. If you have a model in mind, okay, this is how I'm going to measure, this is how I'm going to get a data about environment, then you look at available technologies which are cheap, which wouldn't allow you to make funding proposal first. It will allow you to actually hit the idea right away. And these are the technologies which are cheaper. You can just buy them off the shelf. And they have a lot of documentation already available so that whenever you have a trouble finding what you have to do, you always can look up and see, okay, someone has already done similar project with this particular technology. Maybe I can use this technology for this particular model. And that's where I find that prototypes can come into the market much sooner, that people don't have to wait for years of R&D and looking for making things. You can start 3D printing your idea right now, and then you can actually merge it with the available technologies, and you can put the prototypes in the market. So the time limit which it takes for traditional ways of innovations to come into the market can be much higher. Now, I'll give you an example that this is a phone satellite. This is actually, all of us have smartphones, but there are some people who thought, why can't we use smartphones? Why can't we use smartphones for climate monitoring? After all, a smartphone has every kind of sensor. You have a gyro sensor there, there's a gravity sensor there is an accelerometer, there's a luminosity sensor, and as well as there's a temperature sensor. Now, how many people can actually start programming their smartphones to use those kind of sensors to look at the local problems and solve them? So the cost of building a satellite, for example, which could be in thousands of dollars and require a lot of R&D, there are people in the universities who could actually open up a smartphone and you can start building your own satellite, which will at least will be providing you with a working model on what you can do. Now, how faster than that we can go? But the idea is to not look at the technology just in form of a box, but to actually think ahead from the technology. Open that smartphone, check it out, and see what kind of components you can use from them. And that's where the innovations will happen. So since I am interested in climate change, I'm interested in agriculture, I always keep looking on what are the kind of sensors which are available in the market which I can procure with very little money, basically, not more than $2, $3. I mean, can I make something from them? So we all know climate change is caused by automobile emissions. It's caused by things like greenhouse gas emissions, including from methane from agriculture. Now, look from some kind of sensors which are available in the market. Can I measure carbon dioxide? Can I measure carbon monoxide? Can I measure ozone, nitrogen dioxide, sulfur dioxide? And then you can look at imaging. I mean, imaging should be pretty easy because, the cameras have more powerful, our phones have much more powerful cameras than most of the other instruments. So the idea is to look into those kind of technologies, look at the radio frequency networks, as well as on-demand services. Like we know about quadcopters and drones. Now the idea is, can I fit those low-cost sensors on a drone and fly it over a coastal area, or fly it over a forested area, or fly it over an industrial complex to start measuring what are the emissions which are coming up and whether those can be used to identify what kind of emissions those are and whether they're following the rules or not. So the environmental COTS market is really growing up. Now, I'm going to focus only on a very specific case study which we did. This is about the odd-even rule in Delhi. I come from India, and in India, early this year, for 2 weeks, they had this experiment called the odd-even rule. I'm sure many of you might have heard of that. The idea is that on odd number dates, like on 1st of January, 3rd of January, only the odd number cars would be on the road, whereas on the 2nd January, 4th January, 6th January, only the even number cars would be on the road. Now, these kind of policy decisions are very useful, but unless we understand what have been the outcomes of that and do it very quickly so that we can pour back the outcomes back into the policy-making process. So I thought, why don't, since I'm a maker and I like to make a lot of things, I thought it would be good to have an experiment where we can start measuring the pollution levels, how there have been changes during the odd-even rule, whether they have varied at what time, and whether there are any specific findings which we can communicate to the government and to the people so that we can go for better policy making. Now, this is an example of COTS. This is a sensor, basically, used. This is the Arduino up there, and these are the sensor, and these are the temperature and the moisture sensors. So the idea is, can we quickly, maybe in a matter of couple of hours, are we able to, build together using whatever is available in your house or whatever is available in the market to put together a sensor which you can place in different places and start measuring data, and do so at much faster than anyone else. So this sensor, particular sensor which I made, it costed like $30 because $15 for Arduino, and there's an optical sensor here which measures 2.5 microns of pollution, basically. And 2.5 microns means that kind of pollutants which can directly enter our lungs. They do not get filtered through our nose, so they do the maximum damage. And can we use programming skills to make something like, which can measure the data? So it was a family project. These are my kids, and we all wrote that paper and measured the data together. So for 14 days, we stood at different intersections in Delhi. We noted down pollution levels every day, by taking readings which were for 30 minutes to 30 hours. The 30 hours reading were from the calibrated readings from our home. So the idea was to go every day. So we went to 12 different locations to measure pollution. And, and we even actually took the sensor up in the aeroplane to get some calibrated reading of what would be a clean air sample look like. So, and then we wrote our own program. It's not a very difficult program. Anyone, with a basic language of C, Arduino can write it. I mean, you don't even need to hire anyone. So that's the idea. This is something even school kids or even college kids can do on their own. And this is the first reading which we got from our sensor. And you can see how, as the morning happens, this is the reading. I mean, this is counterintuitive. The maximum pollution was there when there were no vehicles on the road, actually. In the middle of the night, actually, this is when or towards the evening and the late night, that's when we found that was the maximum pollution. Whereas during the morning, when the odd-even rule was in place, you can see that the pollution has come down when there were vehicles on the road. And again, during the evening, the pollution level came up. So that was something very different, which we communicated back to the policymakers that, look, there is something happening, but you have to rely on why this is happening. This is the data which was never shared by the government, because obviously they wanted to show that the pollution levels have come down, it's working fine. But often we have to take whatever government tells with a dose of salt. Because we added a humidity and a temperature sensor also. There's a small humidity and a temperature sensor in this one. We found out that as humidity increases, like during the day or during the evening time, when the humidity is increasing, the air is becoming heavier, actually the pollution, the smog is settling down. So the pollution concentration is going up and up. Whereas we found out in the morning when the temperatures are higher, because of convection current, because the sunlight is there, it raises the air up. We found out that pollution levels are going down. So on a typical sunny day, we found out that the pollution levels would be far less, even though there are a lot of vehicles on the road. Whereas even if the odd-even pollution level was in effect, and it turned out to be a very moist and a low-temperature day, the pollution levels were higher. So this is something, from a $20, $30 sensor, you can end up communicating back to the government. And this is something we talked about, the face masks, because whether having a face mask, wearing a face mask helps or not. So we found out that with the mask, the pollution level were 4,000 particles per 0.01 cubic feet, whereas without the mask, it was almost double that. So even a 50 cents, basically like 10 rupees or 50 cents mask is able to cut down the pollutants by 50%. So it's a very singular kind of effectiveness we were able to find out using the sensors. Now, interestingly, while coming to San Jose, I switched on my sensor in the aeroplane because I find that's a very fun thing, because when we are landing in a city, you are actually getting sensing from what is really up there, and slowly, because the aeroplane keeps taking out fresh air from the outside and it pumps it back into the cabin. So you can see that as the aeroplane is, at the higher level, you can see the pollutant level was 2,000. But as the aeroplane starts coming down, you can see the Costa Rican air starts to enter the air cabin. And you can see the pollutant levels are going up. So this is the reading from 13 September when I came. And this, I tried really to find out, maybe because of my language skills, I was not able to find out any website which is giving live particles per ppm readings of air pollution in San Jose. So I couldn't get a comparative readings. But this was the reading when I went out for 1 hour. I switched on the sensor, and I found out that this is the pollutant readings is between 8,000 to 12,000 particles for 1 hour in the afternoon. So if you just compare it, the ppm readings of 2.5 microns, which causes the maximum damage, in Delhi, it actually should be micrograms, sorry. It's 140 micrograms per cubic meter, whereas the World Health Organization says 20 micrograms per cubic meter, and San Jose was just above the limit of 32 micrograms per cubic meter. So that's good to know that something like that is happening. But I have a feeling that the sensor measured a little bit less because it did rain and the air got cleared up yesterday. So the chances are that on a normal day when there's no rain, there would be a higher pollutants in the level. So I think it's something you have to go back to your own policymakers to have this kind of reading available at a crossroads and everywhere. And if not, then I think maybe there is a scope for any startup company in San Jose to start crowdsourcing of this kind of information available so that you can you can activate this, and then people on the road can start selling face masks simply because the pollutant level is higher, and you can prove it with a reading that the face mask is going to cut that particular levels by 50%. So again, as I said, we came across some findings from our experiment that when is the best time to go out, when is the best time to stay inside the house. We also found out that the reading was far lesser when we were near the trees or in those intersections wherever trees were planted. And because there was an effect, so that means we found out that the vegetation grown on the roadside did help curb the emissions. We also found that the local factors matter. If there's a celebration like in the New Year's night, when there was a lot of firecrackers bursting, there was huge spikes in the emissions. So local factors do also matter. Finally, I think the future is bright. In spite of all those things, the future is bright because a lot of startups have come up using environmental COTS, basically. For micro-weather data processing, forecasting, you have the SkyMet, for example, coming from India, which can provide very micro-level kind of data on weather patterns. You have a crop insurance services that, as with climate change, it will be difficult to get fodder for the livestock. Now, can you price the fodder based on the availability in the future? And can you insure the livestock for the people? And, so there are a lot of things which have come up. We organize a lot of hackathons and gaming sessions so that younger people from universities, college, and even school levels can participate in those gaming hackathons, and they start looking at technologies and see what they can build in 24 hours, so that they don't just come to a conference to think. I think the idea is to do something and leave after doing something from there. And I feel that Costa Rica is way ahead also. I just looked on the website and I found that this was one of the global nominees in the NASA Space App Challenge. It came from San Jose, the Plant It, where the users are able to see what trees are good for planting in the community they live. And this is, again, an app which was built up using available technologies in a matter of 48 hours. So the idea is that if you have a problem, you have the right kind of technologies available to you, and you have the willingness to slog over 40, 60, 80, 100 hours and not worry about who's going to fund your projects, who's going to market it, what are the trade barriers left. I think the future is very bright for all of us. Thank you.
Thank you very much.